Starting with the name of Allah. My name is Sher Ali Askar and my group member Zishan Ali. Assalamu alaikum to all of you who are watching my video. We are from Mining Engineering Department, University of Engineering and Technology, Lahore. We are assigned with the project of coal near Kalabagh, where longwall mining method is running, but due to very high stresses they want to change their mining method from longwall or shortwall mining method to room and pillar mining method to control the high stresses and proceed their mining uh, proceed their coal seam project. Also, we have to check the stability and the feasibility of room and pillar mining method on that area and to design the whole underground mine project. Starting with the given problem statement, we have maximum coal depth of coal seam is 800 meter, thickness of coal seam is 2 meter, the roof comprises of Khevda sandstone, the overburden is Chorgali limestone and the floor is Namal limestone which is 10 meter thick. We have other information like the coal seam is inconsistent, the joint sets are present throughout the formations in roof and floor. We have to design the whole mine and we have to change the longwall method to the room and pillar mining method. According to the guidelines given by Dr. Zakai Mad in the complex engineering problem, we start our work by computing the rock mass properties by using rock lab, as there are many publications regarding rock Kalabagh area. So we compute and from the internet source the value of UCS, the value of rock property, the value of D and Young's modulus for sandstone and limestone for both, and put that input parameters in the rock lab and find out the rock mass parameter, which are tensile strength, compressive strength and Young modulus of the rock mass. You can get all the data in my report submitted with this. Finally, by using different formulas, we have computed 19.6 megapascal of vertical stress and 25.5 megapascal of horizontal stress. The question given in the guideline, we have flat jack experiment failed. We noticed that flat jack experiment failed due to its usage near the surface of opening and due to high tensile stresses, and also flat jack experiment failed due to the pressure may not be entirely transmitted to the whole surfaces. Another question given in the guideline is overcoding is a right approach. So we can say that overcoding is very precise method, but the only demerit is its expensiveness. If there is no matter of economical parameter, then we can use it overcoding as a best. The next task we have performed according to guideline is mine design. We have select a mine opening dimensions as width 20 feet, height 10 feet, and we have computed vertical stress of 19 megapascal, horizontal stress of 25 megapascal, while tangential stress of 45 megapascal and radial stress is 0 there. So on the basis of this mine opening dimensions and stresses, we have designed it on phase 2D to develop a factor of safety and search out that mine opening is stable or not. In designing, we have designed mine pillars. We have selected suitable dimensions of width of 40 feet, length of 40 feet and height of 7 feet for a mine pillar, and we have calculated loading stress of 29.4, and we compute that the safety factor is 1.5, which is safe enough to for working, and we have computed for recovery for this mining method of this dimensions is 55%. Now if we move towards the level plan of our room pillar mining method, so we suggest that the mine opening entry have 3 room entries of with 20 feet wide and 60 feet center to center spacing and a cross cuts of 20 feet. And if we talk about the main panel entries panel. So it has 7 rooms which are 20 feet wide, 60 feet center to center spacing, and a crosscut of 20 feet. The next task in the line of guideline we have performed is rock support system. The rock support system, in rock support system we use the value of GSI given in the statement of problem, which gives us the value of RMR for both sandstone and limestone. The average value for both RMR of sandstone and limestone, we have select that there is a good rock. On classification system, the good rock needs the rock bolts of 3 meter long and spacing of 2.5 meter and short cutting of 50 millimeter in crown where required. Numerical method for rock support system, we have used phase 2D as finite element modeling software. By drawing excavation in the phase 2D, we have seen that the excavation is safe enough that no failure occurs around it. You can see in the diagram that there are stresses, but there are normal stresses. By bolting, we have reduced all the stresses which are applied on the excavation. Now if we move towards the last part according to the guideline, that is high stress scenario. In this section he want that what if they use the same mining method, that is short wall long wall mining method, how they can reduce the high stresses. So we can say that by using side excavation, by using self blasting, and by using a cuts in the gob area, by minimizing the dimensions of the gob area, by initiating the cuts, they can reduce the high stresses. And the next question is, if they ignore the high stresses, so what happen? So we can say that the rock burst, mine subsidence, environmental degradation, and mine may collapse. The last but not the least question is, if they mine massive deposit under this scenario of high stresses, so we can answer this by saying only rock burst, mine subsidence, mine collapse, and environmental degradation may happen. So we suggest only this thing, that they have to change their mining method from long wall mining method to room and pillar mining method.